right, so here's another one, and you're thinking, oh, I can just set the arguments equal, but no, you got to check and look. There's something else hanging out there. So this isn't just log of some argument equals log of some argument. There's this pesky little 2 here, okay? And that 2 makes it so that we can't just set the arguments equal because, you know, 2 times something doesn't equal something, right? So what can we do with our log rules that we could get that 2 into the argument? It's like Dora the Explorer. We could put it up and we could square it, right? So log x plus 2 squared, right? I can just bring that 2 up into the exponent equals log of x plus 4, right? Okay, awesome. So here I'm at there, and now since I have log of some argument equals log of some argument, I can just set the arguments equal to each other. So I can say x plus 2 squared equals x plus 4. Now, the first thing I know you're going to want to do is you're going to want to take this 2 and you're going to be like, oh, that's x squared plus 4. Don't do it. Don't do it. It creates like black holes or something. You just can't do it, okay? But remember, functions don't distribute, so we can't just take that squared and like distribute it in, right? We have to actually square the whole value. So we have to square x plus 2. So, you know, there's lots of ways you could do it. You could do FOIL in your head. A lot of people can do that. That's totally cool if you can. But I'm just going to remind you, just in case your brain melted over this break we had, I'll just go ahead and remind you, we could do it with a box. So this would be x squared. This would be 2x. This would be 2x, and this would be 4. So x plus 2 squared is x squared plus 4x plus 4 equals x plus 4. Okay, so now we're here, and it is what? It's a quadratic, and we know how to solve quadratics, right? We got to get them set equal to 0, and then we factor or use the quadratic formula. Okay, we can do this, right? So how do we get this everything on one side? Well, let's subtract x from both sides, and we're going to end up with x squared plus 3x plus 4 equals 4, and then we're going to subtract 4 from both sides, and we get x squared plus 3x. Now 4 minus 4 is 0, and 4 minus 4 is 0, so we just get x squared plus 3x equals 0. And now you're like, but I don't know how to solve that. And you're going to try to, like, a lot of people try to like subtract 3x and divide. No. Once we have a quadratic set equal to 0, all we do is factor it, okay? And when we factor, what's the very first thing we always check for? A greatest common factor. So do these have a greatest common factor? Yes, they do. It's an x. So that's x plus 3 equals 0, okay? Now we set each factor equal to 0, so either x equals 0 or x plus 3 equals 0, right? That's how we find, because the zero product property tells us that either one of our factors has to be equal to 0. So either x equals 0 or x equals negative 3. Those are our two options, okay? These are the two possible solutions, but we have to check for extraneous. See, you thought you could get away from my ridiculous singing by going online. Silly mortals. All right, so we're going to check. We're going to see if I plug in 0, does it work, okay? So I'm going to start. I'm going to plug in 0. 2 log of 2 equals log, log of 4. So let's grab our calculators and check that. Log of 2 times 2. That equals that big mess. And then what's log of 4? Oh, yep, they're the same answer. So it checks out, okay? So 0 checks out. So again, our answer is not this 2 log 2 equals log 4. Our answer is x equals 0 makes this true. Okay, that's what makes it true. So our answer is x equals 0. Now let's check negative 3. So we have 2 log of negative 1 equals log of 1. Uh-oh! We have a negative as an argument, and we can't have a negative as an argument. Now, if you came down and plugged it into this one, you would have gotten out something that works. But here's the problem. The reason we check for extraneous solutions is because sometimes we do so much algebra that we really mess up the problem. And so we always have to check for extraneous in our original equation before we did any manipulation to it, okay? So when we put in negative 1 to this one, it doesn't, or when we put in negative 3, we get negative 1, it doesn't work. So negative 3 is extraneous. So our only solution that makes this true is x equals 0.